All right, now we've got a small single-phase motor here. This is a capacitor start motor. It's a single voltage 120 volt motor, so we've got our 120 volt run winding here. We've also got our start winding here. Our start winding is connected through a centrifugal switch and with a capacitor in series to that winding, and that's what will give us our phase shift for our starting torque. So with this motor, when we get up here, so that motor starts up. Now this motor is running in a clockwise direction. If we want to change the direction or rotation of that motor, this motor, all we do is change the polarity of this auxiliary winding. Now in the field it's not going to be drawn like this, but the auxiliary or the start winding in any single phase motor is always numbered terminal 5 and 8. So that's all you need to remember on a single phase motor to reverse them is whether it's high voltage or low voltage, you're going to change the polarity or change the connections of terminal wires 5 and 8. Swapping them will change the direction. So now this motor is turning counterclockwise. Okay. The importance of that start winding, if we take it right out of the circuit, just take one wire out, and take all these out. If we try to run this motor just on the run winding, when we energize it, it starts really slowly. If there's any mechanical load on it at all, it's got no starting torque, but you can mechanically spin it and it'll take off in that direction. So that was counterclockwise. We can also go like this and that motor will run clockwise. So because of that cross field, the cross field principle that a single phase motor operates on, until it initially gets started, it has very, very little torque. I could easily hold that back by hand without the start winding. Can't do it with the start winding connected. I can't hold it back. It'll take off whichever direction it's wired for. So the importance of that start winding is to get that rotor initially moving so that the cross field the crossing magnetic fields can maintain rotation and speed it up. The amount of starting torque that a single phase motor has is all based on what we do to get the phase displacement between our auxiliary winding and our run winding. If we didn't have the capacitor in here, we can have just a single centrifugal switch running through that auxiliary winding, and it'll still start. It'll still turn in whichever direction you've wired it for, but the starting torque will be quite a bit lower because you don't get as much phase shift when you're only varying the resistance and the inductance of the windings. So there's our single phase motor. How to start it, or what's going on when it starts, how to connect that auxiliary winding. Again, these are terminals 5 and 8. If you want to change the direction of the motor, you just swap them around. And again, with no start winding, that motor may start, but it doesn't take very much at all to keep it from starting. You can see that cross field action getting it to rotate, but as soon as it does actually take off, then it's got full torque.